it to you? Have you received the link?
Yes, sir. Yes, sir.
Yes, sir. We have received the link.
But somebody said just now that he did not receive the link.
No, sir. Sorry, sir. I didn't check it, sir.
Okay, thank you then. It's okay.
Sir.
It's all right. If you have received it, it's all right. All the PPTs, all reading material, it will come in that Google Drive now. It's only 50% of the officers who have switched on their mobile. What about the rest? Mr. Vijay Pal Bana. I think I'll have to take I have to call the individual officer to know what is the issue, why he is not, he or she is not switching on his mobile or the video. I'm getting echo. Please mute your mic. Mr. Haninder, 302. Mr. Haninder,
Yes, sir.
why are you not switching on your video? I will wait till all of you switch on your video. Mr. Ankit, 315.
Sir.
And why are you logged in from two devices?
Sir, actually, I was logging in from my laptop, but video was not working, so I logged in from my mobile again.
So then you disconnect from your disconnect the link from your laptop.
Yes, sir. Sure.
Mohit, Mr. Mohit, 375. Mr. Mohit, are you there or not? Mr. Mohit Kumar, 375. Who's CR for 3B?
Morning, sir. Sir, I'm Suchita Rural, sir.
Yeah, tell Mohit Kumar to talk to me after the class. He has logged in and he is thinking that nobody will come to know that he is not there in the class. Please don't switch off your video. After every few minutes, sometime, I will check again who has switched off the video, and I will ask all of you individually, why have you done so? If there are any issues, I have already requested PST to join this session. He may be coming for a few minutes. You can discuss with him if the videos are not working in your hostels. So, good afternoon, friends. We will start the presentation where we left yesterday. Today I will talk about the green initiatives, and it is one of the important responsibilities for electrical power department. And a lot of green initiatives have been taken by the department, and I will briefly go through all of them. The first one is, what is the energy consumption that we have in India, in the Indian Railway? We consume somewhere around 20 billion units per year, and which is approximately 2% of the India's total power consumption. So we, as an organization, we are one of the biggest organization which consumes approximately 2% of the entire power consumption that takes place in India. And the overall energy consumption of 20 billion units, out of these 20 billion units, somewhere around 17 billion units, they are being used for electric traction purpose, and the remaining 3 billion units, they are being used for non-traction purpose. We have already decided ourselves that by the end of year 2030, we will transform ourselves as net zero carbon emission mass transport network. And it is possible only if we change or shift our entire energy requirement on renewable energy. When we are going to get shifted as net zero carbon emission mass transport system, our entire energy requirement, it will be met using the installations which we are going to install in the railway land. The entire energy, it will be fulfilled either by solar projects or by wind projects, and we after 2030 we will become the first railway of our magnitude to become a green mode of transportation. So it's an ambitious target, and the way things are moving right now, we will be able to achieve this target by the year 2030. Let us see, where do we stand today? The present installed capacity for solar and roof, it is somewhere around 100 megawatt. We have already installed 100 megawatt of wind power plants and approximately the same amount of solar rooftop plants. And we have also decided that by the end of year 2021 and 22, 1000 megawatt of solar power plant will be installed in railways. And out of the 1000 megawatt of solar plants, 500 megawatt will be land-based solar plants, and another 500 megawatt will be solar rooftop plants. And in addition to the solar energy, we are also exploring wind energy. And as a result of it, it has been decided that we will also install the additional capacity of 200 megawatt wind power plants. So this is the first target which we have to achieve by the end of year 2021 and 22. Whenever we talk about land-based solar plants in railways, there are three issues that we should know. First one is the resources, because unless until I have the land, adequate amount of land, it is not possible to go ahead with the ambitious project of installation of land-based solar plants. So as of now, we have already identified that we have 51,000 hectare of land, which is available to us right now. This land is either available in our colonies, in our administrative offices, or the land is available on either side of the track. So we have a large amount of land, which is, as of now, it is not being used for any useful purpose. It is not, there is no construction, there is no planning for construction in future, and the land is also not under green cover. So as it is, the land can be used, and that in that particular land we can go ahead and install the solar based projects. If hypothetically, as and when we are going to use the entire 51,000 hectare of land, we will be able to install 20 gigawatts of land based solar plants as per the present technology. In the present technology of solar system, the conversion ratio is somewhere around 10%. When I say conversion is somewhere around 10%, that means whatever amount of energy that is falling on the solar panels, only 10% of it is being converted to electrical energy and it is being stored. Rest of the energy is going back to the environment. In case, and a lot of development work and a lot of research work is being done all over the world, through which we are trying to improve the efficiency of the solar panels. So there is a possibility that during the next 10 years, if this efficiency increases by 50%, say we reach somewhere around 15 to 18% of the conversion ratio, then the total amount of electricity that we are going to generate out of this 51,000 hectare of land, it will be much more than 20 gigawatt. So this is the projection which we have done as per the present technology which is available to us. As a part of it, we have already decided to go ahead with the projects worth, or the total installed capacity for those projects are 3 gigawatt, and we have divided them into 3 different categories. And all these projects, they are being handled by REMCL. I gave you one slide where the role and responsibility of REMCL was explained. So all the contracts, they are being opened by REMCL. They will also complete the entire tendering process. They will award the contract, and finally it will be awarded contracts along with the agencies. They will come to Indian Railways, and we will start, we'll start the execution of the work. So as of now, all the 3 tenders, they have already been floated and they are in different stages of finalization. So far, this is the progress as far as the land-based solar plants are concerned. We have 2 megawatt of grid-connected plant which is installed at Rail Coach Factory, Raebareli. This was the first major installation that we had in Indian Railway, and a work is already in pipeline. It is already in progress, where we are going to install 50 megawatt of solar plant at Bhilai. And to install this 50 megawatt of solar plant, we have used 300 acres of land, and it is expected to be completed by the end of January 2021. So this is the present progress that we have. Mr. Akansh has asked, what is TOD? TOD is tender opening date, the date on which we have opened the tender. And now the bids, whatever bids that we have received, they are under scrutiny with the tender committee. The other project or the other target which is there for us to get implemented is related to solar rooftop plant, and we have to install 500 megawatt of solar rooftop plant by the end of 2021 and 22. This is the planning. Whatever that we are going to install for as a solar rooftop plant, it will be used, all the energy that is going to be generated, it will be used for non-traction purposes. That is the first decision that we have taken. It will be used to meet the energy requirement for our offices, colonies, and our station premises. And the installation will be done through PPP model, that public-private partnership model, with 25 years of agreement. And now the basic question comes, why have we gone for PPP model? There are 2 or 3 important issues which made us to take this decision. The first one is the finances, because if we want to install 500 megawatt of energy, and then we need finances if we want to install it on our own. Whereas when I choose PPP model, triple P model, the entire cost of transportation, installation, and operation and maintenance of the solar panels, it remains with the agency who has installed the solar system. So he will engage the manpower, he will depute some manpower, and he will guard the installation at the same for the next 25 years. So as a result of it, railway does not have to spend any money for the installation of solar rooftop plant. Then what is the responsibility of Indian Railway? On part of Indian Railway, we give a commitment to the agency that we will not ask him to vacate the land for the next 25 years. It means we give him a guarantee that we will not we will not make any plans for the development of the land which is already handed over to the agency. That means we have given him the right of use for the next 25 years, whereas the ownership of the land remains with Indian Railways. So it's a win-win kind of a situation where the agency is getting land free of cost, and I am also in a position to get the energy at a cheaper rate. So the third aspect of PPP model is that we execute a power purchase agreement. In the power purchase agreement, we mutually decide at the rate of purchase of electricity. Right now, whenever we are executing the power purchase agreement, the per unit cost for the electricity is somewhere around 3.75 to 4 rupees per unit, whereas we are paying somewhere around 7.5 to 8 rupees per unit to state distribution companies. So therefore, the moment I change my requirement from the distribution companies to solar based system, I immediately start saving 50% of the cost. The entire cost becomes 50% of the original cost. So therefore, PPP model is being encouraged all over India, and a lot of agencies are coming forward to install their systems in our territory. This is the progress which we have made so far. 100 megawatt is already installed at more than 900 stations. Orders have been placed for the balance quantity for another 550 stations, and another 200 megawatt works. They are under different stages. They are either in the tendering stage or in the stage of finalization of the contract. So this is the progress as far as 500 megawatt of solar rooftop plant is concerned. Along with the solar energy, we are also exploring the wind energy. So far, we have installed 103 megawatt of wind energy in railways. The maximum installation, it has taken place in Maharashtra in Sangli district, and it followed by Rajasthan and Tamil Nadu. The most notable installation is ICF Tamil Nadu, where we have an installation which has a generation capacity of 100 megawatt. The other planning is that additional installation of 200 megawatt. It is to be installed by the end of 2021 and 22, and the tenders have already been floated for installing the wind energy in Indian Railways. Incidentally, we already have in Nair, we have a solar installation of 100 kilowatt, which is the solar panels. They are installed on roof of all the hostels, on the roof of on top of Cybrary building, on top of Manthan building, and we have some solar panels which are installed on top of the on top of this sports complex. So the total installed capacity in Nair is 100 kilowatt that we have as on date, and we commissioned it during the last financial year. The other concept which is now being seen and observed in India is the concept of green railway station, where the entire electrical load of the station, it is met through either solar or wind energy. That means it is being met using the renewable sources of energy. And so far, 16 stations, they have been declared as green railway stations. Vaishno Devi is one of those stations which is energy surplus stations. That means the amount of energy which is being generated at Vaishno Devi is more than our requirement. So the additional energy that we are generating, it is being given back to the state distribution company, and we are getting rebate for whatever amount of energy that goes back to the discom companies. Similar to green station, we have the concept of solar section on Indian Railway, where all the stations in that section, they are green stations. So far we have only one such solar section on Indian Railway, and it is in South Central Railway. The total number of stations are 8. and we have installed 37 kilowatt power solar off-grid panels along with the inverter and batteries at each station. And the advantages are that we are saving, not only we are saving rupees 5 lakh per annum, but there is also a reduction of 49 metric ton of carbon dioxide carbon footprint per annum basis. So these are the another two advantages whenever we go for any renewable sources of energy installations in our railway system. This is something which is new, and not many people, even in Indian Railway, who are working in Indian Railway, know about it. There were two pilot projects which were commissioned for installation of solar panel plants along the track to generate energy for traction. This particular concept. It is being tried for the first time on Indian Railway, where we are using the spare land which is available along the track, and whatever amount of energy that is being generated, it is directly going to the traction system. The two pilot projects have been piloted by, one is piloted by BHEL, another one has been piloted by REMCL, and they are at different locations. Both of these pilot projects, they have been commissioned. They were commissioned during the month of August this year, and now we are monitoring their performance. The photograph which is available on the screen, this photograph was taken at Divana. At Bina. This particular photograph was taken at Bina. So you can see the number of panels which have to be installed are quite many. There are many panels which have to be installed to generate 1.7 megawatt of energy. The other advantage of installing the solar panels along the track is that whenever we install a solar panel, we also protect our land from encroachment. You people will come to know that it's a big problem for the posted officers to ensure that there is no encroachment on our land, because there are a lot of land bhoo mafia who are very active, and they are always on a lookout to encroach government land, because they feel that it is very easy to encroach government land, and at the most the government organizations, they will go to the court, and after some time the case may get diluted, or the concerned officer may get transferred. So therefore there is a tendency that the bhoo mafia, the land mafia people, they try to encroach our land. So whenever we install such panels along the track or near the railway station, our land gets protected indirectly, because the agency who has installed these solar panels, he deputes his staff to guard the land. And once the solar panels are installed, even the land mafia people, they also don't want to encroach the land, because there is no scope for any further encroachment. So this is also being considered as a very good strategy, or as a very good method to protect our land from encroachment. Therefore, whenever we are planning to install solar panels in the colony, it is always preferred that we should install the solar panels at the periphery of the colony, so that it acts as another boundary wall and our entire land gets protected. The other one is very common, that is solar street light system. It is designed for outdoor application, and it is an ideal application for LC gates and campuses and street lights. We have already decided to man all level crossing gates. There will be no unmanned level crossing gate in our system. There are certain locations where we don't have any supply from the distribution companies in the near the railway track, near the LC gate. So therefore, in order to ensure proper working and to increase the comfort level of the gateman, we have installed such solar street lights wherever there was a requirement. So these are very easy to install, very easy to commission, very easy to maintain, and doesn't take much of technology or much of skill to ensure that they remain in working conditions. So we are encouraging use of solar street lights, and they are also very cheap as of now, as on date. The cost of one solar street light is somewhere around 25,000 rupees or so. So it does not cost much also. So it has basically four components. The first one is the solar panel, solar photovoltaic module. It has a battery set, battery bank, where to take care of the energy requirement during night time. Then it has a light fitting, and there is a pole structure on which the entire all the photovoltaic module or the battery is mounted. There are some other green energy conservation methods, measures which have been taken. All the fittings have been replaced by LED. Yesterday, somebody asked about the measures which we have taken to improve the energy efficiency at the railway station. So this is the I answered yesterday also, and today also I am saying the same thing. Not only at the station, but at everywhere we are replacing our fittings by LED fittings. All ACs to be at least 3-star rating. Earlier there was it was not mandatory. Now we have made it mandatory that only star rated product, wherever it is available, it will be procured. It may be fans, it may be ACs. The bulk compressors are being replaced by smaller compressors. In the workshops, in the loco sheds, we had a compressor room where a bulk compressor was commissioned, and the pipelines were running from one section to another section of the workshop, and there was a lot of leakage in the pipeline. As a result of it, the bulk compressor were not energy efficient and they were running throughout the day. Now it has been decided that we will discontinue the bulk compressors, and in place of the bulk compressors, we will install smaller compressors on the shop floor itself. So as per the requirement, the smaller compressor can be switched on and switched off, and the energy efficiency also gets increased. The water coolers to be replaced by water dispenser. Earlier we were having water coolers of the which were having a storage capacity of 50 liters or more than 50 liters, and the water coolers, they were running even on the weekends when the offices are closed. The water will continue to be there. It will used to be on, and there was a lot of energy which was getting wasted. So now the water coolers are being replaced by water dispenser, which are much smaller in size. Use of solar geysers and 70-30 platform lighting, which I have explained yesterday. So these are some other measures which have been taken to ensure that the energy is being conserved on Indian Railway. Now, along with whenever we talk about the electricity, we also talk about electrical shocks. And the basic definition of electrical shock is that when electricity passes through a human body, we feel an electrical shock. So there are different strength of current and their effect on a human body. That is how it is divided, that if the strength of the current is between 1 milliampere to 8 milliampere, it is just bearable. We feel that yes, we have come in contact with the live wire. And if the current is above 200 milliampere, it may be fatal. There may be some serious issues. So therefore, we have to be very careful that we avoid coming in direct contact with the live wire, and only the trained person, he comes to attend the faults which has taken place in the system. And the easiest way and the simplest way is earthing. If we have adequate earthing, if we have the earthing arrangement which is in working condition, then it works as the protection from an electrical shock. And basically, what it does, it provides a path for the fault current to flow to the earth, so that the dangerous potential does not get developed, and the excess potential which has developed, it gets discharged, and the excess current then goes to the earth. And it also causes the protective devices wherever we have installed. It may be either a circuit breaker, or it may be a simple wire fuse or a simple HRC fuse. Whatever it is, the protective device, it acts in such a manner so as to switch off the circuit that has the fault. So the faulty circuit, it gets isolated, and the healthy circuit, it remains in the service, and thereby we can avoid any further damage which can happen due to the electrical shock. These are the earth value, the prescribed earth values in our system. the low voltage circuit is 100 ohms, and high voltage circuit is somewhere it is less than 0.5 ohm. So these are the two values. Please remember these values. It may be useful for you in future. So therefore, these are the two earth values which are there. Now, another issue which always comes in light is related to electrical fire, and there are different causes which can cause electrical fire. I have mentioned three major causes which may happen in our working, which may lead to electrical fire. First one is overloading of equipment, and this is another problem when we design our offices or building. Whenever we construct a new office, the requirement of electricity or the requirement of electrical load, it is being provided by the user department. There is a possibility that we are constructing a PRS, and some drawing comes to electrical power department that this is the requirement of air conditioning, this is the requirement of lux level, and this is the requirement for stores, and this is how the overall structure or overall building will look like. We calculate the electrical load and we design the system accordingly by taking care of the suitable size of the cable and the protection devices. Over a period of time, we add more air conditioning equipment, we add more rooms, and we expect the everything will be we will be able to take care of all the additional load. As a result of it, the system over a period of time it becomes overloaded, and there are many cases where the overloading has taken place. So as a result of it, if the overloading is beyond a certain limit, it may cause electrical fire. Then poor maintenance, it is another problem. Poor maintenance may be because of two issues. The first issue may be because of a lack of willpower of the staff to do the proper job, because he is not alert, he does not want to do the proper job, he wants to complete the job in 5 minutes time and want to waste or spend the rest of the time doing some other activity. So that may be one reason. The other reason for poor maintenance may be because he does not have the adequate amount of tools, he does not have the adequate suitable material to be replaced. So that possibility is also there, that although the person is willing to do the work, but he neither have the equipment or the tools to handle it, or nor he has the proper material to replace it. So as a result of it, he has no choice but to do a poor maintenance. So the poor maintenance can be maybe because of the human problem, or it may be because we have not provided him adequate equipment to replace it. The third one is the wrong electrical connections. When we do the wrong electrical connections during the maintenance, and as a result of it, we bypass the safety devices. So if the safety devices are bypassed, then there is a possibility that electrical fires may take place. Akansh has asked, sir, is there any arrangement being done to counter lightning bolt which may accidentally fall on the line? Like, for example, lightning conductor. Yes, we do have lightning conductor. And if you notice our palace building, we have a lightning conductor on top of the dome which we have there. So a lightning arrangement is always there to take care of the lightning which keeps falling on the conductors. Some of the preventive measures that we prefer to take, and we always talk about taking these preventive measures. They are like avoiding overloading, proper maintenance, quality workmanship, ensure protection devices are in circuit, testing and calibration, and earthing. So these are some of the measures and simple measures. These are some very simple measures which can be taken by all of us, and as a result of it, there is a possibility that we avoid electrical fires. Now, let me stop this. Not stop. I will get diverted from whatever that I am teaching to preaching. So now, what happens whenever we get posted on our working post, we work very efficiently and we try to give the best which we can give. Everybody appreciates, most of the time everybody appreciates our good work, and they sometimes people expect that we will do some shortcuts so as to achieve the target. But there are two things which you should always keep in mind. One is the output and another one is the safety of your man and safety of the installation. You may do a very good work for the entire period or entire year, but a single accident or a single casualty, it will spoil the entire work, whatever that you have done during the year. People will forget all the good work that you have done during the rest of the year. People will remember you for the accident which has taken place during your tenure or the casualty which has taken place during your tenure. So please be careful that even if it amounts to slowing the work, never compromise on the quality and never compromise on the safety. Safety is foremost. There is nothing which is beyond safety. So whatever you do, wherever you get posted, never ever compromise the safety. Sometimes you will realize that in order to ensure the safety, the progress of the work has slowed down. But never mind, because if the progress of the work has slowed down, your boss will shout at you only for 1 day or 2 day or 3 days, at the most for a week. He will be annoyed, he will be unhappy with you because you have not done the job on time. But if there is a casualty or if there is an accident because you have done the job in a hurry, people will not forget you for the rest of the year. So therefore it's your choice whether you would like to tolerate that pressure for a week, or you would like to live rest of your life with a guilt feeling that because of some inaction on your part, either an accident has happened or a casualty has happened. So even in my during my tenure, I may not remember all the good work that I have done, but whenever some accident has taken place or some casualty has taken place because of somebody's inefficiency or because of some reason, I remember each and every incident till date. So that is the problem, that we may forget the good things, but all the bad things that happen with us during the service, we carry it them from one posting to another posting. So therefore never compromise on safety, because if because it's not good to live with the bad memories of our posting. This is how the electrical power it interacts with the other department. I have mentioned it over here for the interaction. It's a summary of their duty. Like with the operating department, they interact for yard lighting, running room on ASM rooms, for SNT, modification in case of electrification, signaling supply through auxiliary transformer, electrification of LC gates, AC in RRI, and then engineering for water supply, wiring in the quarters, new platforms for commercial, and similarly for mechanical officers, with the mechanical officers, yard lighting, pit lighting, washing lines. So you can see that electrical power department, they interact with all other departments. As I have already told earlier, that electrical power department, they work as the contractor for all other departments. We have certain important acts and codal provisions which are applicable for electrical power department. The three important one I have mentioned over here: Indian Electricity Act, the Electricity Rule, and the Track Crossing Regulation. And there is a difference between the act and a rule that I'm trying to mention over here. See, the difference between act and rule is that act is said to be the primary legislation. It is the law which has been passed by both the houses of parliament and approved by the president. So that is the definition of act. And then we have rules, and rules are framed to frame methods and procedure to make the act operational. So you will come across a lot of acts and the rules which are applicable to us and which are to be used for our working. So therefore, it is important for us to know the basic difference between act and rule. This is the list or the bibliography where you can find more about electrical power department. IREN, it publishes the journals. It publishes journal on regular basis where the topics and the articles from the officers of Indian Railways, they get published. We have IS code, we have acts, and we have the circulars. So in case somebody is interested to know more about electrical power, these are some of the locations or some of the documents which are available on net also. So that was all about the electrical power department. Now let us look at the second responsibility of electrical power department, which is related to lighting, and that is maintenance of electrical equipments other than air conditioning in the coach. So the second responsibility which is there for the electrical power officers is related to maintaining the electrical equipment in both AC coaches as well as on non-AC coaches. Let us see how the train lighting system evolved over a period of time on Indian Railway, or rather in the railways as such. The initially lighting in train, it was done using either candles, lamps, oil, or later on by gas. And they were all fire prone items. So there were cases of coaches getting fire. The coaches were also of wooden body. So the fire cases were quite severe. And as a result of it, the system was changed and batteries were introduced for electrical lighting so as to prevent the fire accidents. And the system of generation of electricity also got changed. And train lighting by electricity, it was introduced on Indian Railway in 1897. Initially, we started with 24 volt DC system, and later on we switched over to 110 volt DC system, and we switched over to 110 volt DC system because of the certain advantages of 110 volt train lighting system over 24 volt DC system. These are some of the advantages of 110 volt DC system. It has lesser weight per kilowatt. Then additional load is possible. It is possible that in case the generating system of one coach becomes defective, it is possible for me to extend the power supply from the adjacent coach. It was not possible in 24 volt coach system. As a result of it, if something goes wrong with the generating system of 24 volt coach, the coach will remain dark during the entire journey, which was quite uncomfortable to passengers. So therefore, we have changed over to 110 volt DC system. The current will be less, hence cable connections will be smaller in size. As I have increased the voltage level, for the same amount of power, I require less current to be drawn. As a result of it, I can afford the size of the conductor to be on the lesser side, and therefore the connection will get. The fourth is the less maintenance as compared to 24 volt DC system. The 24 volt DC system was an old design. It was an obsolete design. So no R&D or technical inputs were being given. As a result of it, all the generating equipments which were used in 24 volt DC system, they were maintenance prone, whereas the 110 volt DC system, they required less amount of maintenance. Let us see different kind of generating system that we have on Indian Railway. We have self-generating 110 volt DC system. Then we have mid-on generation, the 415/110 volt AC system. In the mid-on generation, we use two DG sets. And the rating of the DG set is 30 kVA. Each DG can give an output of 30 kVA. And in the mid-on generation, it was used for passenger trains. And over a period of time, it is now also becoming an absolute design of having a generating system on a coach. The third one is end-on generation system, where we use power cars to generate electricity, and we have DG sets in the power car. The output of the DG set, it is being fed to the coaches using 750 volt 3-ways 4-wire system. And the power cars, they are the high capacity power cars, because we have two power cars in one train, and each power car, it is equipped with two DG sets. So in a Rajdhani or Shatabdi kind of a train, we have 4 DG sets which are placed in two power cars, and at a time we use either two DG sets, or at the most 3 DG sets are required to meet the entire load. So therefore, we use redundant capacity which is already provided in the power car to take care of any additional requirement. The fourth one, which is the latest mode of generation for a coach, is the head-on generation, where we are using the electric locomotive to meet the requirement of the trailing load. Earlier, this technology was not there. Electrical locomotive or diesel locomotive, it was used to generate the power for the tractive effort, and we were either having a self-generating system, or we were having end-on generation kind of a system to take care of the electrical load for the coaches. Later on, it was decided, why do we have two generating systems, one in the locomotive and another one in the form of power cars? Why not we club both the generating equipment and provide the generating equipment in the loco itself? So therefore, we came up with the concept of head-on generation, and we have provided another additional winding in the transformer on the locomotive, and that additional winding takes care of the load which is required for the trailing load. Mr. Vishishk has asked, if I have pronounced him correctly, why do we use DC supply in coaches? Why not directly use AC? The AC equipments use AC, that is one thing, but earlier the light fittings and the fans that we were using, they were all on DC. So therefore, we were using DC systems, and the generating system was also designed accordingly. Now, when we are using end of generation kind of a system, we are generating AC directly, and we are using AC as of now. Some of the components, let us talk about some of the components of self-generating system of the coach. The first and the foremost is the generator, which is suspended. So the first and the foremost is the generator. It is suspended from the underframe of the coach, and it is driven by a flat belt axle pulley. The second component of the generating system is rectifier cum regulator unit. It rectifies AC to DC and regulates the output voltage level. The third one is the battery. It is the power. Whenever the power is supplied to the load, and the power is supplied to the load from the battery when the train is stationary, and the so these are the three major components which have been used in a coach as far as the self-generating system is concerned. During the earlier AFP, I have asked the questions like mention the main components which are being used in the self-generating system. So you were supposed to write on any two of them, like you can choose either to write a short note on generator or on rectifier. Sometimes I have asked whether RRU is used in self-generating system or it is being used in the EOG kind of a system. So with this self-generating system, this is something which has been asked regularly in the previous AFP program also. Some of the major train lighting equipments which are there in a system have been listed over here, like axle pulley and V-belt. The other one is the alternator, the rectifier cum regulator unit, the battery is another component, the junction box, rotary switch. So these are some of the components which are being used in the train lighting equipment. This is how the alternator looks like, and for the train lighting equipment, the rating of the alternator is 4.5 kilowatt, 110 volt system, and we have 4 V belts which are mounted on one pulley, and this is how the V belts look like. Then for the AC coach, we have 18/22 or 25 kilowatt 110 volt alternator system, and the rating of the alternator is higher than the rating of alternator which is being used for non-AC coaches. The reason is simple, because the energy requirement is much higher as compared to non-AC coaches. We use 6+6 V belts on 2 pulleys. We have 2 pulleys on either side of the alternator, and as a result of it, we are using 6+6 pulleys. Now, the pulleys are again the mechanical component, and since the alternator is mounted under the coach, there is a possibility that the pulleys, the belts may get snapped during the run. So therefore, under the worst condition, even if we have 4+4 pulley belts on either side of the alternator, we will be in a position to generate the electricity. So when I provide 6+6 V belts on 2 pulleys, 2 belts on either side of the pulley, they are spare battery, they are spare pulleys to take care of the any problem which may happen during the run. This is how the axle pulley looks like. Then we have the rectifier cum regulator unit, which is being used to convert the voltage level and the voltage. And this is how the battery bank looks like in a AC coach. It is mounted under the coach. So these are some of the components which are there for self-generating arrangement. Here I have tried to show the arrangement, how it works. It's a very simple diagram through which I have tried to explain the generation or of a self-generating equipment. And this is same whether it is an AC coach or it's a non-AC coach. We have the axle, and we have the alternator. But the axle and alternator, they are coupled or linked together using the V belts. So whenever the axle rotates, it also makes the alternator to rotate. As a result of it, the electricity start getting generated. The generated electricity goes through rectifier and a regulator unit. Rectifier which rectifies and regulates the voltage level. It changes the waveform, and the power supply, it goes to the battery and it goes to the fan and the light circuit. The battery and fan circuit, they are parallelly connected to the rectifier and cum regulator unit. The reason for connecting them in parallel circuit is that during the stoppage, the battery takes over and it provides the necessary or required electricity for operation of fans and the light circuits. Whereas during the run, the battery also gets charged along with supply of the electricity to fans and light circuits. So this is the simplest diagram through which we can see how the entire generating system in a self-generating coach, it takes place. This is another diagram to explain how the train lighting circuit, it works in a coach. Again, it is same in both non-AC coach as well as in AC coach. We have the red wire is the positive wire and the green wire is the earth wire or the negative wire. Now, the design of the circuit is made in such a manner that we run positive wire on one side of the coach and the negative wire on the other side of the coach. So as a result of it, the positive circuit and the negative circuit, they have physical isolation, and it is done purposefully to avoid any reason for short circuiting or for any reason of for the fire cases which can take place. Now, if we see the circuit, the power supply, it comes out of from the positive terminal, it goes to the equipment and it goes to the negative circuit. And when the circuit gets completed, the when this power circuit gets completed, the fans and the lights, they start working. So this is how the basic diagram or basic system it is there in an AC coach or in a non-AC coach for the train lighting circuit. We have different levels of protection in a TL coach. We have 3 levels of protection in a train lighting coach for in the train lighting circuit. The first one is the negative fuse box. If the earth fault is serious, or if it is not possible to isolate the fault immediately, the fuses which are provided in the negative fuse box, it will get activated, they will get blown, and the entire coach will become dark. So this is the highest level of protection which is available in a coach. We also have the junction boxes. We have 2 junction boxes on either side of the coach, and we have different fuses which are provided in the junction box, and each fuse takes care of one major circuit. The entire circuit is divided into 2 circuits. They are known as L1 and L2, that is circuit 1 and circuit 2. So in case there is a major fault in one of the circuit, that circuit will become out of service, and this associated fuse, which is an HRC fuse, which it will get, it will give the indication. So this is the second level of protection. And then we have the third level of protection, which is the simplest level of protection, where we have a fuse distribution port, and it takes care of the earth fault which takes place in a particular branch. So we have 3 levels of protection, and depending upon the severity of the fault, either one of these the protection system, it will become activated, and it will also give an indication to the maintenance staff as to where to attack and how to take care of how to remove the earth fault or how to remove the problem which has occurred in the circuit. So this is how the different level of protections they are being provided in a coach. We have certain limitations as far as the self-generating system is concerned. And these are some of the limitations which I have mentioned over here. There may be external heating of underslung equipments because they are mounted and there is no protection to them. The maintenance of batteries is another issue. And the total life of batteries is 4 years. After every 4 years, we have to replace the batteries. The batteries is a costly equipment, and the disposal of batteries after the completion of the codal life, it is also very important issue. The electrical officers, they hand over the released battery to stores department, and the stores department, they dispose of the battery through auction to a vendor who is authorized to take care of the batteries as per the Battery Disposal Act. We have an act, Batteries Handling Act, which has been formulated, and it is applicable to Indian Railways also. So the stores officers, they have to take care of it, that batteries have been discarded and the batteries have been disposed following the provisions which are mentioned in the Batteries Handling Act. I think it was the act was enacted in either in 2002 or 2006, somewhere between 2000 to 2010. Then the maintenance of pulley belt system is also very tricky, because we have the mechanical component, that we have the pulley, the belts, and the belts, they may get elongated during the summer period, and they also have a weathering effect, and they become brittle after giving certain period of service. So therefore, and the alignment is also very important, that unless until we have an adequate alignment and proper alignment between the pulley and the belt, there will be continuous rubbing, there will be a local heating effect, and the belts will melt and they will fall down. So therefore, maintenance of pulley belt system was a painful exercise for the maintenance staff during the earlier days. Then the generating capacity is also limited in the self-generating system, because the size of the generator cannot be increased. Because if I want to increase more, if I want to increase the capacity of the generator, I have to install a bulkier compressor, bulkier generator in the coach. Now we have limited space under the coach. I cannot increase the size of the generator indefinitely. So therefore, that limited space also puts a restriction on the upper side of the generator. And as a result of it, there is a limit beyond which I cannot have any generator which can be installed in the coach, under the coach. The other one is, it is not suitable for large electrical loads of trains such as Rajdhani and Shatabdi. As a result of it, we moved on from the self-generating system, and the first stage was mid-on generation system. In the mid-on generation system, it started working on 110 volt system, and there was one power car which was installed in the center of the rake, and it was having two DG sets. Each DG set was supplying electricity on either side of the power car, and it was used for the trains which were having frequent stops. Basically, it was being used for the passenger kind of a train, and it was suitable for slow moving passengers train. Why there was a requirement to have mid-on generation? Because of the very nature of the service which was there for the passenger train. In case I want to have a self-generating system, I should be able to run the train at a higher speed, and the number of stops should be less, so that adequate amount of electricity can be generated. If I have a train which is stopping after every 5 minutes, and it does not move beyond and where the average speed is somewhere around 15 kmph, then generation of electricity using self-generating system is not possible. So therefore, we had no choice but to go for mid-on generation system. Because for every alternator, there is a cut-in speed, and only after the generator attains that speed, the generation of the electricity starts. In case of the system, in case of the train lighting coaches, that cut-in speed is somewhere around 19 kmph. Only after the train attains a speed of 19 to 20 kmph, the generator starts giving the electricity. So therefore, the self-generating system was not suitable for passenger trains which were having frequent stops and which were not having average higher speeds. So we went for mid-on generation kind of a system. Mid-on generation system, it had certain advantages. It was a centralized control in all AC coaches. We could eliminate the batteries, and the maintenance was reduced because all the maintenance related to electrical department, it was concentrated in one coach only. So the maintenance staff were not supposed to see the working of the generating equipments in each and every coach. The disadvantage is that we waste one coach length because one coach was used as a power car. We moved on to end-on generation system, and it is the most preferred generating system as on date. In this particular system, we have two power cars at both end of the train to take care of the hotel load requirement, that is the lighting and AC coaches. And Rajdhani and Shatabdi, it works on EOG coach. If you see the schematic which is placed over here, we have two generator car. Each generator car has two power cars. Sorry, each generator car or the power car, it has two DG sets, and we have two feeders. We have feeder 1 and feeder 2. There are two feeders which run from end to end in the rake, from one power car to another power car, and at a time we use either feeder 1 or we use feeder 2. So one of the feeder, it is a redundancy, or it is the safety measures, or whatever you call it. So in case something goes wrong with the feeder 1 wire, then we use feeder 2 wire. All the officers who are attending this seminar, this particular presentation, all of you belong to technical services. So please always keep in mind that we have to build a redundancy into the system. Nobody will accept that because there is a failure in one particular arrangement, the entire system comes to a halt. So whenever you are designing a system, please make sure that adequate redundancy is built into the system itself so that your life remains comfortable. And the maintenance, you don't have to undergo lot of pressure to put the system right as early as possible. That is why whenever I am discussing the subject, I am also giving you the hint as to why the RDSO has gone ahead and built the redundancy into the system itself, so that the pressure there is not much of a pressure on the maintenance team. Like when I said that we went in the railway station, we have the system of 30% or 70%. So we have the system of emergency light or essential circuit and non-essential circuit. Then we take the power supply from two different substations. We have two DG sets. Why have we done so? We have done so because so that there is a redundancy which is built into the system, and we get sufficient time to maintain, or to so we get sufficient time to take care of our installations. Similarly, in the case of the coaches, we have 6+6 is the number of belts that we have provided, and 2 belts are surplus belts, which will take care of any failure in the axle pulley belt system. Similarly, in the end-on generation system, we have one feeder which is redundant. There is no need. The entire system will work efficiently, but I need another feeder wire to take care of any breakage in the feeder wire, to take care of any problem in the couplers, because all these feeder wires, they are connected from one coach to another coach through the couplers. There is a possibility that there is a loose connection in the coupler. As a result of it, the power supply is not going from one coach to another coach. So I may have to change over from feeder 1 to feeder 2. So in order to maintain continuity of the power, we have built lot of redundancy in our system. It may be electrical system, it may be mechanical system, it may be electronics or civil engineering system. So wherever we, as a maintenance team, we have to ensure that we have some margin which is available to us to take care of our maintenance requirements. Yeah. Now, each power car, it is having two generating sets of 500 kVA capacity, and electrical power to the train, it is supplied through two sets of feeder at 750 volt, three phase, 50 hertz. Now, let me ask a question to Mr. Vikas Gupta. Mr. Vikas, are you there? Mr. Vikas, are you there? Roll number 371. Mr. Vikas is not there. CR, please ask Mr. Vikas Gupta to talk to me after the class. Let me ask another question to Mr. Shubham Kumar. Mr. Shubham?
Yes, sir.
What is the disadvantage of self-generating system?
In self-generating system, the batteries are used, so there is a bulk, there is a more weight, and in self-generating system there is a special means speed. There is a speed after which the generation starts, and the maintenance is more in self-generating system, and the limited power output.
Thank you.
Self-generating system.
Thank you for attending the session seriously. Thanks a lot.
Thank you, sir.
Now we have, similar to the advantages and disadvantages of self-generating system, we also have advantages and disadvantages of end-on generation system. The advantages is what Shubham said just now that we use bulk batteries in self-generating system. So that is the advantage, that is the disadvantage of self-generating system, and it is the advantage of end-on generation system. Then there is no external heating, less maintenance. So whatever disadvantages that we had in self-generating system, all of those disadvantages, they were eliminated when we moved from self-generating system to end-on generation system. However, it had the certain disadvantages. The first one is the higher fuel cost, because we have to use high-speed diesel in the power cars, and the cost of the diesel, it is increasing every year. So therefore, that was the one issue. The noise and smoke pollution, that is another problem that we have faced because of the end of generation system. Although it is not part of the subject, let me also briefly mention there is a case which is already going against railway in National Green Tribunal, and it started in the year 2014. And one of the item or one of the grievance which has been mentioned in that particular National Green Tribunal case is that the railways should take care of the noise and smoke pollution which is there because of the DG sets which are being used at our railway stations, the DG sets which we are using in our Mail Express prestigious trains, and the noise and smoke pollution which takes place because of the diesel tractions. That case is still going on, and the railways has taken a plea in the National Green Tribunal that the noise and the smoke pollution is taking place because of the technology. Railways cannot do much about noise and smoke pollution, because if I am using the DG set, I am only using it, somebody else is designing the DG set for me. And whenever I'm using a DG set, now noise is bound to happen. At the most, I can provide some kind of acoustic enclosure to control the overall decibel value of the noise which is getting generated. But I cannot remove the overall noise pollution. But how, we argued on this particular plea that this is something to do with the technology. It is nothing to do with the maintenance. But National Green Tribunal, they did not agree on this issue, and they said that railways should take measures to change to a better technology so that the noise pollution and the smoke pollution which is there because of the train operation, it can be reduced. And this was also a background why we decided to go for HOG kind of a generation system, and this is also one of the reasons why we have decided to go for complete electrification of our broad gauge network. It's now almost 6 years since the case was initiated against railway, and it is still continuing. Some of you, when you get posted, you will also come across that particular case, because that case is not applicable to only one particular railway station. It is applicable to for all the railway stations. The other one is the reduction in commercial space, because we are using the space for 2 power cars, and we also need the staff to operate and maintain. Having a adequate number of staff is a luxury now. It is very difficult to get adequate number of supply or adequate number of staff to work for us. There is a large number of vacancies which are available in our workforce. So therefore, nobody would like to waste staff and manpower to maintain and operate the power cars during the run. Chirag has asked, sir, apart from HOG, EOG and SG, is there any other technique under development or in practice in some other railway abroad? Yes, people are not talking about hydrogen generation. They are talking about hydrogen generation in the coaches itself. We have yet to explore that technology. Britain has already commissioned 2 trains where they are using hydrogen power. They are using hydrogen to generate the electricity. It may be introduced in near future in Indian Railway. As of now, that is the another technology which is being used. People are exploring, especially European railways. They are exploring the technology. Solar power, it is not being used as of now, because the available space which we have on top of the roof, it is quite limited, and it cannot take care of the entire air conditioning and hotel load which is required in the coach. So therefore, the solar roof panels at the on the roof of the coach, it is already there in Indian Railway for non-AC coaches. But it is not possible to have solar roof panels on top of AC coaches and at the same time to meet the entire load. Akansh has asked, is there any scope for use of rotary engine because of its efficiency and reduced vibrations due to being balanced? Rotary engines where? In the DG power car, in the power cars? Akansh, will you explain or will you like to comment on your question? Okay, next one is, sir, any particular reason we call it hotel load? Yes, there is a reason behind it. When we don't have in our Rajdhani and Shatabdi train, we also have the pantry equipments. We have a pantry car and then we have the pantry equipments in our AC coaches which are being used to heat the food before serving it to the passengers. So because we are using the electricity for the comfort of the passenger by way of providing air conditioning environment, lights and fans, and at the same time we are using the electricity to take care of the pantry cars. Therefore, the word hotel load, it has come from the hotel industry. It has come from the hospitality industry. So therefore, this hotel load is the appropriate word which is to be used whenever we talk about the load requirement of the energy for our prestigious trains. So it has a precedence, and we have taken it from the hospitality industry. Sir, use of rotary engine for traction. Yes, we are using rotary engine for electric. We have the motors for the traction purposes. We have the traction motors. Why do we want to use a rotary engine? Because if I want to use rotary engine, then we will have to use the diesels also. So therefore, for the electric locomotives, we are using DC motors. We were earlier using DC motors, and now we are using AC motors. The next one is the head-on generation system. And now this is the latest one which is being introduced, which has been introduced in Indian Railway. The power is provided from the locomotive, especially WAP 7 locomotive, which is a 3-phase locomotive. We will talk about 3-phase locomotives when I cover locomotives in the next class. Then we have 1000 kVA hotel load converter, which are fitted in the locomotive to convert single phase into 3-phase power supply for generation of train lighting and air conditioning load and for the pantry car. Now EOG rakes, they are being converted into HOG rakes. Until last year, 168 trains they have been converted so far in the HOG kind of an arrangement. This is how the circuit looks like. We have the power generation of electric power. It is coming from the locomotive. We have the power car in between where we have 2 DG sets, and we have a control system, control panel, where the power supply from the locomotive as well as the power car, it gets terminated. We have the power cars, they are being manned by the maintenance staff. So they rotate, they select whether the power supply from the locomotive should go to the locomotive coaches, or the power supply which is getting generated in the power car, that should be extended to the coaches. So depending upon the requirement or depending upon the health of the loco or the coach or the power car, the power supply either from the locomotive or from the power car, it gets extended to the coach. We have the bus coupler and we have 2 feeder wires. So at a time, the control system is designed in such a manner that at a time only one set of feeder wires can be used, and both the power supply cannot be extended by using both the feeder wires at the same time. These are the advantages of HOG system. It's pollution free, cost of power production is cheaper, and more commercial space is available because of elimination of one power car. As on date, the railway board has issued the instructions that we will replace only one power car, and over a period of time, the instructions may come that we can also get rid of the another power car. But as of now, we are eliminating only one power car. So one power car will remain in the system, and other power car will go out of the system. This is the end of this part. Now, I think I'm running slow because I have not covered air conditioning. I will cover air conditioning in the next class. I will start the session with the air conditioning, and then after that, I will continue with the locomotive. My next class is during the next week now. I think it is somewhere on 15